Hello everyone. In this video we're going to be solving a polynomial system. We have x squared plus 2x plus y equals 4 and y squared plus 2y plus x equals 4. So it's nice that we have the same number on the right hand side. I'll be presenting two methods, and let's start with the first one. So my first method is kind of like how not to solve a problem. So let me go ahead and number these equations, number 1 and number 2. And from number 1, I'm going to isolate y. Y becomes 4 minus x squared minus 2x. And then I'm going to go ahead and substitute that. I know some people don't like the way I write the 2. Sorry about that. So I'm going to write it like this maybe. So I can go ahead and substitute that into the second equation. So let's go ahead and replace y with that. 4 minus x squared minus 2x squared plus 2 times y, which is this, plus x is equal to 4. Again, this is how you should not be solving a problem. Now, when you go ahead and distribute, let me go ahead and give you the equation from here to save you the trouble. If you go ahead and expand this, simplify this, combine like terms, whatever, so on and so forth, you get the following quartic equation. You get x to the 4th power plus 4x cubed minus 6x squared minus 19x plus 20 equals 0. That's easy, you can do it. So this is a quartic, but one thing I want you to notice, a lot of times I keep telling you always to check first the sum of the coefficients and the sum of the odds and the evens in case -1 is a solution. In this case, 1 plus 4 plus 20 is 25. And -6 plus -19 is -25, so the sum of the coefficients is 0. Which means x equals 1 is a solution. Which means x minus 1 is a factor. Which means we can divide by x minus 1 and factor it again. And we happen to find that x equals -4 is another solution, which means x plus 4 is another factor. After finding two of the factors, you take out a quadratic, and then you end up with another quadratic. So quadratic times quadratic is what it is. So let's go ahead and write this in the factored form, and then I'll give you the solutions. All right? So this can be written as x minus 1 times x plus 4. By rational root theorem, you can definitely check factors of 20, and this leading coefficient is 1. So I'm only going to be checking the factors of 20, which aren't that many. So the other factor is going to be x squared plus x minus 5. And we're going to set it equal to 0. From here, we get the following. X equals 1. Now, remember, we used the formula from the first one. We wrote y in terms of x. So if x is equal to 1, I can plug it in and find the y value. And y becomes 1 as well. Is that surprising? How about x equals -4? If you substitute it, you'll notice that y is also -4. So that kind of gives us the equal values. But what about the quadratic? X squared plus x minus 5 equals 0 is going to give me the following roots. X equals -1 plus square root of 21 over 2. And x equals -1 minus square root of 21 over 2. But guess what? These are only the x values. And then from here, we can find the y values. And the y values are just going to be the conjugates. Because just like before, we did this in a recent video, they need to be conjugates so that their product and sum are both rational numbers. Okay, so those are going to be the x, y values. And we got 4 ordered pairs. 4 ordered pairs from here. So let's go ahead and take a look at this second approach. Second method. For my second method, I'm going to be doing the following. Let me rewrite the original equation. X squared plus 2x plus y is equal to 4. And y squared plus 2y plus x is equal to 4. Since both of these equations are equal to 4, I can set them equal to each other, right? Because if two things are equal to each other, then they're equal. So x squared plus 2x plus y equals y squared plus 2y plus x. All right. From here, nothing cancels out, but I can put everything on the same side, putting the x squared and y squared together. X squared minus y squared, 2x minus x is going to give me positive x, and y minus 2y is going to give me a negative y, and the whole thing is equal to 0. Beautiful. Now, this is factorable by grouping, because x squared minus y squared is a difference of 2 squares. Make sense? We've done this many times. So x squared minus y squared can be factored as x plus y multiplied by x minus y. And x minus y has no common factors, but we can always take out 1. Let's do it. And then we get the following. Now, notice that x minus y is a common factor. Therefore, we can take it out. X minus y multiplied by x plus y plus 1. And the whole thing is equal to 0. I know this looks a little complicated, but guess what? We have 2 factors and the product is 0, therefore we're going to set each factor equal to 0. Let's start with the easier one. Y equals x, or x minus y equals 0. So x minus y equals 0 gives us y equals x, just like before. And now remember, one of the equations, we can use this. So I have x squared plus 2x plus y is equal to 4, and I'm going to use y equals x. Obviously, this is a lot simpler than the first one. X squared plus 2x plus y, which is x again, equals 4. This gives us x squared plus 3x, and then 4, of course, I can just go ahead and subtract it and write it as a trinomial, which is factorable, by the way, because you can just write this as x minus 1 times x plus 4 is equal to 0. And from here, guess what? We get x equals 1 and x equals negative 4. But our initial assumption was the y equals x, so if we find the x values, we found the y values. From here, x minus 1 equals 0 gives us x equals 1, and that gives us y equals 1 because y and x are equal. Remember that? From the second equation, we get x equals negative 4, but since y and x are equal, y is also negative 4. Awesome. So for the particular values of x, we got this. And now let's go ahead and take a look at the second case. The second case comes from the other factor, x plus y plus 1 is equal to 0. If x plus y plus 1 is equal to 0, this means x plus y is equal to negative 1. So this is another equation that I should be using. And if you substitute that into one of the equations, again, I'm going to use the top one, x squared plus 2x plus y is equal to 4. From here, I can isolate y and write it as negative 1 minus x, and I can just go ahead and substitute that into my equation. X squared plus 2x plus y, which is negative 1 minus x, equals 4. And then we get x squared plus 2x minus x, that's going to give me plus x. Minus 1 minus 4 is going to give me minus 5, and we get the same equation. So this equation has, 2 solutions. So x is either negative 1 plus the square root of 21 over 2. In this case, y is going to be the conjugate. Or they'll switch around. If x is negative 1 minus square root of 21 over 2, then y is going to be negative 1 plus the square root of 21 over 2. Along with 1, 1, and negative 4, this is going to give us all the solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.